Natalia, thank you for joining. And
Thank
we
you
have
very much
all
for
yours.
inviting me in this series of talks. So today I would like to talk to you about interactive technologies in modal music performance. And to start, let's discuss about why modal music poses interesting challenges for interactive technologies. So most of the musical tools and algorithms that we have developed today are optimized mainly for Western tonal music, which is primarily driven by harmonic progressions and vertical chord structures. But modal music operates mainly on a completely different logic. It is built on phrase-based musical evolution, and also it unfolds through melodic motifs and stylistic nuances rather than shifts in harmony. And this means that our computational models cannot simply rely on chord detection to understand the musical context. Second and perhaps more technical challenge is the use of microtones and non-Western tuning systems. We're dealing with maybe multiple coexisting musical systems. And usually the standard 12-tone equal temperament often does not apply in this setting. So for an artificial intelligence or a real-time analysis tool, this requires much higher level of precision in pitch tracking and a deeper understanding of the specific intervals that define its mode. Another key challenge is the rhythm. Modal traditions usually often use complex rhythmic patterns that sometimes may even alternate depending on the musical form. So keeping a system synchronized with these rhythmic changes in real time is sometimes could be more difficult. For a digital system, keeping up with this shift in real time requires a lot of flexibility. Furthermore, the performance itself could be possibly classical composition based maybe on a fixed or sometimes complex formal structure, or it could be a contemporary composition based maybe partially in a formal structure or combined with improvisation. So the architecture of the performance could be dynamic. And finally, we have the human and the physical element. The modal traditions are deeply rooted in acoustic instruments, or maybe the human voice. So when performed in ensembles, they are characterized by a very strong acoustic interactions between performers. So the input that we usually have is not, I mean, if we had a keyboard, then the input could be the information of the notes that have been pressed, but when we have the input source using a microphone, the data that we get is in a raw form. So we need more analysis to interact and explore and study this input. So I would like to start presenting some ideas that use gesture as input. And all these tools use the body, the human body, and the motions as a musical interface. So these applications or these tools are gesture. Give me 1 minute, just to move the window. Okay. So these tools create or automate the sound of the musicians, having as input gestures or motions, and present. And sometimes they shape the musical texture according to this input. They use the movement as a continuous source, of musical structure, and enable the performer to engage in a dialogue with the responsive system. Sometimes they offer real-time mapping of gesture to polyphonic textures or to some effects that the musicians could add in their performance, and they support improvisation and other aspects of the performance. Usually the input came from cameras, motion sensors, or wearables for gesture or movement tracking. The first example I would like to share with you is called Polyphonia, and is a real-time portable vocal processing system that I was implemented in 2021. And Polyphonia uses finger tracking and a motion sensor, that is a small sensor that you can see in that image. So we don't need to use gloves or wiring to give input in this system. And it has some vocal processors and a live looping system and also a harmonizer. And also uses as input the microphone's audio signal, and its output is the processed audio signal. So this tool could be used for expanding the possibilities of human voice. We call all these tools. We say that they augment the instrument. So this tool could be used for vocal augmentation. And it was presented in NIME, which is a New Interfaces for Musical Expression conference. It was presented and accepted in 2021. So you can see there an example of the motions and the way that the polyphonies are being enabled using finger tracking. And you can see in that video, you can see a little bit of a performance using also live looping and hand gestures. With the left hand I'm controlling the looping, and with the right hand I'm controlling the polyphonies. I can enable or disable some or add some voices in selected intervals. Another tool, in this picture you can see some movements and some motions that they enable or disable the selected intervals. And in the right image, in the image on the right, you can see the structure, the architecture of the system. Polyphonia takes as input the audio, and it has two main modules, one module for the live looping and one module that enables or disables the selected polyphonies.
Natalia, can I ask you something?
Yeah, of course.
Okay. When you said that you use your both hands, so you had two apparatus to do that, or you could do it with one?
Yeah. I've programmed it to use both hands because I would like to control simultaneously the looping and the polyphony. So
you had two machines.
Yeah, I needed to have two hands, but it's very easy to change the setup of this tool. I mean, I could maybe add some other gestures to control the polyphonies with one hand. Mm-hmm. Actually, the main motivation for that it was because I was thinking that it was more natural, or for a singer to use the hands instead of using foot pedals. It was more natural in the performance, and it was more, let's say, aligned with the body posture of the singer. But I can say that this tool is a little bit outdated, because in 2021 I was using a lip motion controller, because I couldn't find a freeware and decent and reliable tool that it could help me with motion and finger tracking. Right now we have better tools than that. I mean, we have the Google's Media Pipe, which is it can do this, maybe the similar job with lip motion. I give you 1 minute to show you lip motion. I have it with me. The lip motion is a controller. It's like that. Give me 1 minute to. Yeah, if you can.
Maybe you can stop sharing so we can see you a bit bigger.
Sorry, yes. Yes, that's the lip motion controller. It's like a small camera. You put it like there, and you can do some gestures. That camera works also without lighting, because it uses infrared technology. So I would choose the lip motion to do it, because I would like to use it in the performance, and maybe in a setting without good lighting or something like that. But right now, I mean, that was in 2021. Right now we can use the computer, the camera of our laptop maybe, to do the same job, and I can show you an example to understand. So with the lip motion, you need to just connect that to the computer, and it's like you're having a camera. But I would like to show you the Media Pipe system, that it is very reliable. Here, yes, that's the Google Media Pipe. That's an online demo of Google. You can see how good it is with detection of hands. And it can recognize the left or the right hand. So it's very useful for the musicians, and if you would like to develop or to design a software with different roles in right or left hand. And you can see that it's very, very quick. We don't have latency or something like that. So right now someone can develop or implement tools using just the camera of the laptop camera. So if you have some questions, I mean, you can interrupt me anytime. So with this idea that we can use the laptop's camera for reliable motion tracking or finger tracking, we started to use Media Pipe, and then the conference, the NIME Interface for Musical Expression, asked me to be a mentor in, I think, the 2022 version of the conference. And I was a mentor to Monica Lim, an Australian artist and composer, and she would like to create a similar tool that it could recognize that it could do motion tracking and some automation maybe in vocal input. So we used Media Pipe for that, and we were creating a browser-based hand gestural controller. It was created only using the Google Media Pipe, which is open, free and open. And the handmade has mainly 3 controllers. It has the handmade effects that takes as input the user sound input and provides a choice of audio effects that can be controlled by hand movement. Also, it has a MIDI function that outputs MIDI notes or control MIDI values for symbolic use. When we say symbolic, we mean that maybe the user can play a keyboard or an instrument that it can give us MIDI input instead of raw data, instead of audio. And also it has another function that outputs some messages for other users to access hand movement data and pass maybe the data in other applications. So Handmade was presented in 2022, and I would like to share with you maybe a short demonstration of Handmade.
Two pointy fingers there, and that's so maximum distance.
There Monica explains the way that it works, but listen maybe an example.
Arbitrary because it just detects the distance between your the pitch bend and sorry, this is aftertouch and pitch bend. So other than pitch bend and aftertouch, we can also control different just general CC, and you can assign that in your program to various things. In this case, I have assigned it to the wet mix of a resonator effect. And let's say I use my left hand closed for this effect.
In this system, the user can select the function and the gestures. Actually, the user can map the gestures that trigger a functionality of the...
So let's put it on and see what it sounds like. So that's the sound, and if I close my left hand, you can hear the resonator coming in. Okay.
In this example, Monica mapped a resonator with the opening of her hand. Another tool is kinesthesis. It was the main idea of Tilemachos Moussas, which is a composer and PhD students of the Music Studies Department of National and Kapodistrian University of Athens. And kinesthesis is an innovative interactive tool designed for augmenting the voice of singers and actors. And it can modify an actor's voice in real time. It also uses Google Media Pipe for face and hand detection, and it could offer various effects for controlling an actor's voice, like pitch shifting, vocoders, reverbs, and delays. This work was presented in Sound and Music Computing 2022. This is the architecture of the kinesthesis. Also, it takes as input the audio from a microphone, and then it has some vocoders and effects that alternating the original sound. Telemachos used a lot this software in theatrical performances. So let's now discuss another category of software that use signal processing techniques to explore maybe the microsonic structures of music and create textures or compositions. So from gesture-based interaction, let's see some examples of sound level processing systems. Now in this category of software of systems, the signal analysis, the signal processing becomes the musical material itself. We try to decompose the sound into micro events that we could call them also grains. And so granular synthesis is the name of this approach. And granular synthesis works as a bridge between analysis and music generation, and is based on a process that is called granulation. And it means that we're breaking down an audio sample into very small segments of audio that they called grains. One example of this category of software is called OMAX. Is one of the maybe most famous software implemented in IRCAM. And OMAX offers an environment that could learn in real time typical features of a musician style, and it gives the flavor of a machine co-improvisation, let's say, or co-creation. Is based on researches on stylistic modeling carried out by Zahara Sayag in IRCAM and Shlomo Dubnov, and on improvisation with the computer by Asayag, Shemilye, and Bloch. So how OMAX works, it takes as input the sound stream, the audio source of a musician, and re-injects in several different ways the musician's material that has gone through a machine learning stage. So allows a smart recombination and, let's say, transformation of this material in real time. It's like the system learns the phrasing of a musician and try to reconstruct the sound, and controlled by the musician, it can collaborate with him in improvisation. OMAX was implemented by IRCAM, l'Institut de Recherche et Coordination Acoustique à Paris, and they continue and they expand OMAX in IRCAM every year, and they also offer another bunch of software applications that they're collaborating with OMAX. So I have some examples for you to see how OMAX is working. This is in a very simple guitar solo. The sound with distortion is the OMAX that replies. It's like a call and response. This was Dimitri Ismailis, also a student of National Capodistrian University of Athens, interacting with OMAX. And I have also another example with a violin, but it is also integrated another system, an augmentation, violin augmentation system in this demonstration. Okay, I can share with you a link. So let's continue with another project that is called the Cicadas. This is a project, actually the idea, the motivation behind that project was that sometimes composers and researchers in acoustic ecology use signal processing tools and techniques to understand the behavior of insect swarms, their social organization, and how they're divided into groups all over the world. So it's very connected with, let's say, computational ecology or the study of nature. So in that project, we created a computer simulation of a cicada chorus that was created by analyzing the rhythm of three levels of cicada behavior. And this model was inspired by the stochastic methods of Yannis Xenakis for characterizing sonic events in terms of their statistical qualities. And it suggests models of stochastic rhythm that can evoke complex yet natural feelings of movement in music. It was implemented, actually it was the motivation and the core idea belongs to Anastasia Georgaki, which is the head of the Laboratory of Music and Acoustics of National and Kapodistrian University of Athens, and it was developed by Daniel Brown and me, and was presented in Xenakis Centenary Symposium and Ligetis Symposium in Hamburg on 2023. So in this simulation, Daniel tried to analyze the cicada orny songs that originally are made up of short chirps, sometimes interspersed with screeches, and we analyzed the rhythm in three levels. The first level contained the stochastic parameters of the rhythms of a single cicada and the chirps. The second level, in the second level, we studied how these parameters changed in the presence of other singing cicadas. And in the third level, we studied the overall sound of the produced polyrhythms in a group of cicadas. So with that with the simulation, the user can create a different cluster of cicadas, like they were in different trees and they are chirping. And to do the simulations, we used a mathematical model of oscillators that influence each other, and that model was introduced by Kuramoto in 1975. So let me show you a short demonstration of this simulation. The sound of a cicada is generated by synthesis, but it could feed the simulation with maybe real sounds. We did hours of recording cicadas before implementing this simulation. Here you can see three clusters of cicadas. And you can see how the different parameterization changed the sound.
Natalia, could you make the video full screen, please?
Yes. Is it okay? And also there is a parameter that is called coupling strength. This parameter comes from the Kuramoto model, and so the user can change the coupling strength of the different cicadas and how they interact with each other. Later in the video, you can see the results of after enabling all the cicadas in the 3 different trees. But the idea was not to just implement a cicada simulation, but to try to use that in music composition and maybe in real time too, because the user can import different sounds or maybe the sound of an instrument or a human voice in this simulation. And later Daniel, because also he's a composer of electronic music, so he composed a song based on an input of my voice in a folk traditional Greek song, and created a musical composition that was based on this. Actually, he only used this tool later. It's
Η θερμότητα ξηραίνει τα μαλλιά σου. Νέο Pantene Hidden.
About that, you can listen the whole song in the YouTube.
Natalia, can I ask you something?
Yes, yes.
Because I'm sure I didn't understand the whole of it, but maybe I could ask. You have 3 groups of cicadas, right? And each group has inside 3 or more voices.
Yeah, exactly.
And
You can choose. It's custom. You can
Yes.
make your own simulation.
I didn't understand. I found I understand you can. Is it? Do you do it by hand, like to the parameters of how?
The
How long?
correlation.
Yes, I mean the parameters of each group you can set them, adjust them.
Yeah, yeah.
But my question is, where is the influence? There's a influence or confluence here, understood correctly. You know, something influence another thing, but I didn't understand where is that.
Yeah, this is a parameter that it called coupling strength, and you can adjust this parameter to study the amount, let's say, of the correlation that the different clusters have with each other.
So the correlations between the 3 main groups, not inside each group.
Actually, the model studies the correlation between all the cicadas, but I'm not sure if it has an extra parameter for its cluster. But the idea for that was because if someone wanted to import sounds of different, let's say, types of musical instruments, maybe the percussions or maybe the bowed instruments. So it would be interesting to adjust the correlation if you would like to have more or less correlation between the musicians.
So, for example, can you give an example of that? For example, if one group plays more, will the other play less, or something like that?
Yeah, actually, the model tries to blend or to synchronize, in a sense of rhythm, the movement, not by pitching right now in the current state. So actually tries to synchronize the rhythm between the different groups. So that was the idea.
Michali?
Yeah, great. Yeah, thank you very much for the presentation, Natalia. I have one question that is a bit more on the side of analysis. You presented this Omax, right? And you said that the program somehow copies the characteristics of the performer, right? And then you can play along with it or like interact. I guess you can parameterize in different layers, like what it is you are looking for that specific performer. Could you export this data for purposes of analysis? Like if you say these are the three elements I'm interested in on this performer. So if you analyze this recording, can you output elements of phrasing or other idiosyncratic characteristics to use later for analysis?
In my current version of Omax, I think I cannot extract the data.
Okay.
But I'm not sure because they are still expanding the Omax. I don't know if they have other tools that they can do that, or they can export the data. When I was using the Omax, I remember that I could see the parts or the slices or the chunks of my performance that this tool was edited and and tried to get back to me. And also it has a lot of parameters that you can adjust.
Okay, and can I have a follow-up? Christo, is it okay? Yeah. Okay, great.
Sure. I'm not Natalia. I'm not sure if you finished your presentation.
I have let's say.
Okay.
Yeah.
Do
you want me to continue? I have.
Yeah. Then I keep my question for later. Don't worry.
Okay. So. Yes. Okay. I would like to talk to you a little bit about another idea, how we could pass from sound to emotion, or maybe the opposite, and how we could use the biometric data as a part of a musical dialogue. So we could also use biometric or neural signals as a musical input. We could have brain sensors capturing cognitive and attentional states, or physiological data such as heart rate, respiration, or skin conductance as input for mapping biometric signals to sound processes and textures. And so in that way, we could extend our performer system interaction beyond gesture and sound. And we implemented a project in 2023, from 2023 to 2025, in collaboration. Actually, the project was implemented by the Technical University of Athens in a collaboration with the Department of Music Studies of National and Capodistrian University of Athens. And the purpose of that project was to enhance expressivity in music by dynamically adjusting sound effects. And the question for us was how we could combine the biosignal input, music knowledge, and music and emotion labels to alter the acoustic outcome for the sound of a musician. So we created a data set from 26 professional musicians. We created a protocol, actually an instrument independent recording protocol that gradually increased the musicians' degree of freedom, and we gave to the musicians varied instructions regarding expressivity. We also asked from them to tag their performances according to the emotions that they would like to pass to their audience. And we developed a model, like a prototype. We call them prototypes because they are not commercial applications or systems that are officially released in the official stores of Android or Mac or Apple. So we created a prototype aimed at enhancing the musician's expressivity through artificial intelligence tools. And the system alters a musician's sound according to the brain waves or biosensors in real time. I have something to show you if you want to, but let me finish with the other ideas. We could have another category of software that is that aims to educational purposes and on the aesthetic importance of student training, or the development of targeted exercises and selected repertoire, or offering interactive applications for analyzing vocal recordings, or maybe assisting instructors or music teachers in assessing students' capabilities and guide training in real time. I have also an example of this type of software. We implemented with the National Kapodistria University of Athens a project that is called ASMA, and it was focused on the social and aesthetic importance of student vocal training. We developed vocal exercises and repertoire. We created some tools that they analyze the children's voices, and it could extract the vocal profile, the vocal map of their singing voice. They can visualize, these tools can visualize vocal characteristics or help teachers draw conclusions about the student's vocal placement, or help them do a vocal warm-up. These are some screenshots of the students' voices. In the first image, you can see just a tuning tool. In the second one, you can see the formant range profile, which is some diagrams that help us understand how clear is the articulation or the pronounce of the vowels. And in the third picture, you can see some vocal range profiles that show the range and the intensity of the children's voices during their whole vocal range. And finally, we have a group of additional audio tools and techniques that are very famous, or they're very popular today, like the impulse response loaders, that they're modeling acoustic spaces. There are some tools that you can load maybe in the DAW, or you can use them maybe in live performances. They can change the sound of your instrument or your voice according to some profiles that are pre-trained. You can train an impulse response loader to make your voice or your guitar have a different timbre or a different, let's say, sound color. And these tools are very famous also for voice profiling, for timbre dynamics, and they use real-time audio processing to create all this alternation. And to close, the challenges, in my opinion, are to develop tools that they can follow the fluid and the phrase-based musical language while respecting the natural feel of performance, to create systems that can augment but not replace the performance interaction, to create environments where the performer is not just operating a tool but engaging in a dialogue with a responsive system, to investigate how digital methodologies can respect the traditional musical nuances, to explore the balance between structure and improvisation in interactive environments, to see or to discuss how technology can open new pathways for musical expression, and to understand how human system interaction can help us to guide design choices for the responsive tools. So I'm open to questions. Thank you very much for your time.
Thank you, Natalia, for the presentation. Hey, Stella, it was you. So, Michalis, you had your may raised hands. Maybe, Michalis, you want to ask what you were about to ask before or comment?
Sure, yeah. Well, again, thanks a lot for the presentation, Natalia. My questions again about maybe the side of analysis, but also about training, all of these kind of algorithms, because you said something in the beginning, like the differences between modal music or the challenges that you have with modal music, and one of those is microtonality, right? And I guess also phrases or phrasing could be both. I was wondering, because I've seen in the past similar attempts, like from the decade of 2000, like with Jana Kyots and this kind of group. I was wondering, since the pin algorithm exists, I don't know if you are using that,
Yeah, lots.
right? So since the pin algorithm exists, wouldn't it be a possibility that you're feeding information to the LLM or what is it you are working with, in a manner that it sees pitch as a function of time, not as like segmented again and again until these are very small instances, right, that you work with. But all the microtonality for us, for modern music, is not usually a matter of where you play the microton, right? But it's usually a function of time depending on melodic gravity. So I was wondering if that, just using and fragmenting audio in terms of phrases, not in terms of instants, could be a more helpful way to get there, to get into decoding what happens into phrasing.
Yeah, that's a very, very good idea. In my opinion, it's very useful to analyze modal music as, phrase-based, not scale-based. And you have right. Also my opinion is that. But actually, the tools that we have, actually not all, but most of them are Western biased. So when they are doing, let's say, they're working usually as they do mainly harmonic detection, or they try to guess the scale using harmonic information, and they're not so good in detecting, let's say, we have some tools for Macam recognition, but they're not so popular or reliable as the tools that we have for Western music. But of course, for me, it's very important to use the phrases instead of, just segments, to try to extract information about modal music. And also, the yin algorithm is very important for pitch striking, but we need more than pitch striking, to understand the, let's say, the tonic centers of the melody, or maybe the change in a makam, or we need more work on that, in my opinion, to have tools that they could support model musicians in real time.
I agree. I think just the pin is a good starting point, but we don't have. I haven't seen any tools as well that they do automatic processing of, if that would be an estimation of a macam or something. But I was wondering if that's a starting point instead of segmentation. Okay, thanks a lot.
Yeah, thank you.
Orkun?
Eleni was before me, no?
Really? Okay, but she lowered her hand.
Yeah, but being not an expert at all, maybe Orkun can take the floor first.
Yeah, I'm nowhere near an expert on this, but it's super interesting. Thank you very much. I have one question. So you mentioned like natural feeling, right? In terms of the sound that software produces. So this natural, I heard that cicadas, they are the grasshoppers. So you feed them the grasshoppers or something like this, like the sound of grasshoppers, or I don't know, something from nature. So how it becomes natural, the sound for us.
In this simulation, we can just feed the software with every sound we would like, every audio sample that record.
Okay.
Personally, I'm recording a lot of cicadas for hours, to study them and to try to construct the simulation. But in the video I've shared with you, the sound was purely synthesized. It was not an audio sample. It was purely synthesized.
Yeah. Can I have one more question?
Yeah, of course. It's okay for me. Sorry, Chris.
No, I think we are, we are a few participants, so we can improvise.
Okay, just a short one. So when you feed the software the sound of cicadas and then they learn it, but who approves it? Do you come in and give a feedback, or is it fully like several loops that feeds themselves and reach like a saturation and I don't know, the sound that they will or rhythm that they will produce? So is there like feedback, like positive feedback, negative feedback as you feed the neural network or something?
This model does not use neural networks.
No,
Just
okay.
no. Just the Cura model is a simpler.
Okay.
Is
All
a
right.
simpler construction, so it does not learn or have feedback.
Okay.
It
So it
just
takes the input and creates an output, and this is what we listen to. Okay, I see.
Exactly.
All right. Yeah.
I could say that Omax uses more machine learning, and also, of course, MediaPipe and tracking systems. They use a lot of
Yeah.
artificial intelligence stuff.
Okay. Nice. Thank you very much.
Natalia, can I ask you this model in Max? You call it model or program or
Yeah, system.
system?
Yeah,
Is it
system.
is it open? Like
The cicada, yes, is
yes.
open. Yeah, I have the links in my presentation, but I can share to
Oh,
you.
so somebody can download it and play with it, for example.
Yeah, of course. Daniel
Yeah.
Brown implemented that, and it has it's open source and free. It has the Max object in his personal website,
Okay.
but also for doing that, because I don't know. MaxMSP is an optical programming language. It's not free; it's closed. But you can run the objects of MaxMSP without buying the software, so it's possible for you to test it.
Because I use Ableton, maybe is there a way to? I think there is a way,
I
no?
think yes,
Pass it
and I'll text to Daniel, because Daniel, for that reason, he implemented a small
patch.
like a patch, yeah, that it lets MaxMSP to interact with Python programming language, because MaxMSP is not very good in for writing Python, so he created a small patch that is in Python, and it can be used as a medium to communicate with MaxMSP.
Eleni, go ahead. I don't think you need my permission to talk. You go ahead. You are two people, so yeah.
Thank you. Thank you, Natalia. What a nice talk. First of all, I was very happy to learn about all these things, because I knew that Natalia was locking herself up in the studio of the music department for like a year or so. So now I know what what was taking place there. Perhaps one question that arises from someone who is not an expert. I come from a totally different background, but I was wondering, I mean, you spoke about being able to harmonize, being able to loop, being able to improvise together, to compose. I'm wondering to what extent you are able from this type of projects to find out more about the artistic creation, so how processes work in musicians, I don't know, minds, or so can we sort of turn the lens on the musician himself and what goes on while he's doing music or composing or whatever? This is one question. And the other is, I was really surprised by how quickly this changes. You said, I think, Polyphonia, which was a 2021 project, is already passé. So if you could comment a bit on what sort of artists are, where are, I don't know, what sort of musicians are being bred, out of this technology-human interaction. where are we heading, you know?
Good. Difficult questions, both, I think. For the first question, Eleni, would you like to discuss about, I mean, what is the role of the musician as a creator more than a, than a user of an application?
Perhaps this project where you were connecting people with and taking their, I mean, can we learn something about how the music creation process takes place?
Yeah.
I'm not sure. Maybe this is a question that cannot be answered.
Actually, I think I cannot, but maybe I have some ideas. When we studied, because in some projects we did maybe experiments or analysis or try to study, aspects of performance or of creation. So in that project, with the Flow project, we tried to study the emotions of the musicians when performing. And we tried to correlate their emotions with some musical scales, Western based, like the modes, the jazz modes, like the Ionian, Phrygian, Lydian, Mixolydian. And we tried to see if their emotions were changed according to specific, when they performed in different musical scales. So the results were, for me, were a surprise, because when the musicians selected, or when they selected an emotion from a specific list of emotions, actually their audience was connected with this selection. So it was very interesting. When the musicians were performed without expressivity, then the results were not correlated. But when the musicians were performing in different levels of expressivity, we see that we have an alignment with the audience selection. So that's a very small example, but actually most of the tools were created in collaboration with musicians that they would like to find or to explore different ways of expressivity, or to augment their instruments, or to co-improvise with the system, maybe to have some ideas that emerging in real time when they perform. And most of the tools were created after, a professional musician came and said, okay, I would like to have a tool that it can co-improvise with me, or I would like to have a tool that it can enable different audio sources in different clusters to play together, or not to play together, to separate and to come again to align again. Or I would like to have a tool that it would change my reverb, the automation, the effects, according to my thoughts or according to my emotions. So most of the tools were implemented with actually real real artistic motivations. So, but I don't know how they could help someone. I'm not sure, how they can be used, if actually they could be real tools, or used as another musician, or just be like just like small games that a user adjusts some parameters in a PC. That's an open question.
Exactly. Thank you.
And about the second question, actually, yeah, in 5 or 6 or 7 years, a software that you can create maybe is outdated, because like the lip sensor is outdated, because now we can use only the camera to do a very reliable motion tracking system. But also we're now trying to do more things using cameras without and not using gloves or wires or sensors. One idea, and we discussed also with Rose Daly, this idea was to create an augmented lira, Cretan lira maybe, that the performer can change the reverb maybe with a small movement in the hand that holds the bow, Or another idea was to create a
With the
very
mustache of
reliable.
Ross. With the mustache of Ross, he can send signals. Sorry.
Change the reverse.
Sorry, I interrupted you.
Yeah, or we could create maybe very reliable IR loaders that you could use maybe a piezo microphone or a contact microphone in a lira or a violin, and then you can have a sound like you have a large diaphragm microphone in the studio. This could be for me an amazing breakthrough.
Augmented sympathetic strings, lira,
Yeah.
augmented lira with augmented sympathetic.
Exactly. But I don't think that I mean. In one sense, the lira with sympathetic strings could be an all type of acoustic interface, and it's not outdated. It's an instrument that continued to evolve and been playing from a lot of people. So, in my opinion, we can have very different aspects of augmentation that they could still exist, even with created with older tools or older paradigms or motivation.
Geronimo, yeah, go ahead. You're muted for now.
Okay. I'm very interested in knowing how you implement the use of a electroencephalograph in relation with applied to music.
Okay, in that project, we bought some sensors, very, very simple sensors with just 4 electrodes. It's like a very, very, very small.
I understand how that works. Yeah.
Yeah. According to the literature, you cannot do emotion detection with just 4 electrodes. You need maybe 80 or 100 of electrodes to do a reliable emotion detection. But to have maybe 100 of electrodes, you need to have a full head mask, and we would like to create a very simple tool that every musician could use. And of course, you cannot, it's not very natural to go to a concert and to see a musician that wears all this stuff to play music. So we decided to lose some reliability, let's say, on emotion detection to gain a natural sense of performing. So we recorded brain waves and audio data from the musicians who were performing, and then we gathered also some labels according to their emotions. And then we tried to detect the attention and awareness, how stressed or how relaxed they were, also in correlation with the heart rate or the skin conductance. And we tried to create some indexes that they were saying if a musician was stressed or was calm. And according to these parameters, we enable or disable some automations or reverb or change actually this is fully parameterized, you can change whatever you want. And also we did an experiment in lights. We changed the lighting of the concert room according to these indexes of relaxation and attention.
If you wanted to manipulate somehow your music using your electroencephalograph, that would probably be very steep learning curve to do that, right? Because we don't know how to do that.
Yeah.
It would be the spontaneous output that you are using.
Yeah, and also these sensors and actually the cheap sensors that we use, because usually these sensors are very expensive. With the cheap sensors, you have a lot of problems with the signal. They're not very clear. You have a lot of noise, and so it's not very easy to extract reliable results.
All right, fascinating lecture, by the way.
Natalia, I could not help but thinking that when you said it's not normal for a musician to go with a helmet, have you seen Lady Gaga in the Grammys yesterday?
No, she was.
There's a place to put the nay here in the front.
Maybe a new fashion in modal music performance.
Totally. Can I ask something? If I understand correctly, many things of this interaction has to do with adjusting parameters, right? Like
Yeah.
which in a way is the same parameters, but reverb or volume or texture or whatever, or vibrato. But actually, it's different ways of changing these parameters, right? And I was wondering, when you're going more to the artificial, to OMAX, if I understand correctly, which is a step ahead, no? I mean, to something extra. Are there ways? I mean, I don't know anything about it, but I was taking a bit a musician that I like that published that he's a programmer also, and he's using Super Collider. Yeah, and I was wondering this live programming that there seems to happening there, or prepared, or at this, would it, because if I understood correctly, the plus, the extra thing that this does is that, for example, you can talk to the machine in a way that says, when I start to play long notes on the flute, you take another role and you start to do more staccato movements, no? Something that you cannot change directly, maybe with a parameter. Maybe you can, but it's like it's not a decision that the other part takes, no? So my question is, where are we with that? I mean, and if programming is part of your, I mean, this kind of programming, I guess it's part of your work, because I guess programming is part of what you're doing. So that's one question. Because on the also sorry, I thought about it also from my own experience with playing a bit with effects with Lableton live, playing with Ney, and what Eleni was saying a bit, if I understand correctly, how does this have to do with the with the experience of the artist himself, herself, that wants to use it in a in an artistic context, and not just, I mean, of course experimenting, but doing something that musically and aesthetically and artistically is fulfilling. And for me, that is a change, when you can actually not just adjust parameters, but at the same time know there is something that the software that you're using is actually, you can communicate with it in such a way, and that means vice versa communication, no? To understand what you're doing more.
Yes, I'm not so experienced with OMAX use because I didn't implement it by myself, so I'm not sure if my answer is actually right. But when I was using OMAX, I saw that it had a lot of parameters, but not. I've not felt in the previous, but I think I was using it before the COVID era, so it was before 5 or 6 years. So at that time, the OMAX was not, in my opinion, so very well adapted in the real time improvisation. I've tried to upload some previous recordings of my voice and tried, to interact or to use it in real time. But I could say that I'm sure that right now maybe it would be, of course, better in adaptation, as I said, because before 5 years it was very interesting, and also as possibly all of you know, right now the artificial intelligence is very good on style prediction and style on profiling, let's say. So I could say that if we cannot do it, even if we cannot do it very well right now, in a couple of years it will be very good on style imitation or profiling or interact with us. I was remembering in a demonstration of Simone, a robot. I think it was implemented in Georgia Tech, I'm not sure, but it was in a performance of that robot, and the response in the solo, it was very, very good and better than I was expecting. And also it's a very important key point that there are some open source free academic research prototypes and all this stuff, but also there are commercial applications of software. And sometimes, I mean, the commercial, they're more expensive or they can do more things. So I cannot say, maybe in 1, 2, or 3 years we will have an amazing co-improvise software. I don't know, Christos, if it was an answer to your question.
Yes. Some more comments or questions? Yes, Teta.
Hello, thank you very much, Natalia. That was a very nice talk, and it also falls into my own research area or interest, let's say. I might have missed the first part of your talk, and sorry about that, but can you emphasize a bit the connection to the modal music types? So it's like, this is I mean, I totally understand what you've been working on, but how does this specifically connect to modal music performance? Do you treat it in a special way, or it's modal music types? Do you treat them in a special way, or what is your take on that? Because all these tools, let's say, they do have a bias towards, let's say, Western styles of music or Eurocentric music styles, and this might not be, let's say, I mean, these types of music might need I don't know, a special treatment, or what is your take on that?
It's a very good question, actually. Some tools, they are not working in a modal setting like some educational tools because they were implemented in Western musical system in the 12-note Western scale. But some other tools that they can work taking the audio, the raw data as input, like OMAX, they could totally be used in a modal music performance. For me, the challenge, actually the point with the different musical systems is that when you would like to take as input audio and you would like to try to give back sound stream, like for co-improvisational purposes or for accompanying purposes or tasks like that, it's very important and crucial to be able to understand and analyze the structure, the form, the mechanisms that are used, or the musical system. Sometimes in contemporary composition, we can see changes maybe in, or in older compositions too, changes in rhythm or in scales, or and that it could be very difficult, to analyze and understand. I mean, for example, right now the beat tracking, it could work in maybe 4/8 or 16 or 2 or 3 or 5 maybe, but in 13 or 18, I think we're not in this setting right now. Also, we have the task of source separation, that is, take an audio maybe from a studio recording with 10 musicians that they're performing together and try to separate the audio sources. We cannot do that right now. Okay, we can do that, but not professionally, not having, clear sources. And we can do that for educational purposes, or we can try to have some source separation results. But the Western biased tools and apps that do that, they usually try to maybe extract the voice from the musical instruments, or to try to devise the frequency ranges. I mean, to base maybe a middle style frequencies and high frequency zones, and to try to separate the audio in 3 zones. But in modal music, that we don't have harmonic progressions or very clear roles. Or sometimes you have melodic lines that they move very close to each other. All these source separation techniques seem to, let's say, to fail to give results. So for that reason, I believe that it's very crucial, to to do more study and dive in the analysis of modal music by itself.
Okay, thank you.
Can I ask something, Natalia? This, from an ignorant point of view, the theme with MIDI and audio, when we're giving more like an input of audio in a program, why is it so? Is it like uh, is it progressively? Will it be progressively more easy to have, for example, effects that to convert this information to MIDI? Because right now, I think it can be done, but it's a bit basic, right? I mean,
A bit basic, yeah.
but why?
And when you have monophonic, because the source separation problem, for me, in my opinion, is open right now. I mean, if you have 5 violins playing together in an audio file, a mix, and ask from a computer to separate these 5 violins, it's almost impossible because it's not easy to come back to separate the signal, because the sound, I mean, επαλληλία, δεν ξέρω ποια είναι στη λέξη στα αγγλικά. Όταν έχεις επαλληλία.
I don't know it in
In
Greek
English,
either.
when you have a lot of waves come together and they try to separate them and come back, that's not a very easy problem. We can do FFT, Fourier transform, to take the recipe of the frequency, but I mean, every sound has harmonics. So when you listen a note, and let's say this is a note, it's not a very clear note. It has other frequencies inside. So we know how to do an analysis in frequencies to pass from a wave, a time domain that we have the wave, to the frequency domain that we have the recipe of frequencies. We know how to do that, but we don't know right now how we can separate 5 or 10 violins if we have a mix of them, because we don't know how much each instrument contributed. Let's say I'm trying to explain in very simple terms.
But
and when you have a solo instrument playing without, not a guitar, I mean, when you have a violin or a lira playing and you have only one note, it's easier, of course, to take the notes, to extract the notes from the audio. But when you have polyphonic instruments, it's more difficult to do that.
And can I ask you something? Would it be? Does it seem that the MIDI, how you call it, parameters should be revised or even extended in order to accept this more info? Because I mean, in terms of tuning, you have, I mean, the information about tuning exists, right, in the MIDI, but why can't it incorporate the macro tunings?
Yeah, that's a very good question, and I was actually I was thinking a lot about that the last month. How we could have, the MIDI, in the MIDI you can have information for detuning a note, so you can add, you can have a Macam style interpretation of a score, like a Musiki, like a software that can do that. It's not native in MIDI. I mean, we need to use a parameter of MIDI to try to bring to make a MIDI plays modal music. But right now we have MIDI, so maybe this is the most popular solution right now to try to do this with MIDI, because all the score notation software uses MIDI as the main protocol for playing for the playback. So the most popular solution right now is to try to pass to the MIDI messages the information of the tune changing. To be actually, I've before this talk, I was contacted a friend that he's developing a very, very interesting system for playing his keyboards using Macam style of notes. So he created a second keyboard with faders, and he can tune or detune like a canon, like a digital canon, let's say. So he can convert his keyboard to a canon, and he also uses a MIDI. And we're discussing a lot because I would like to see if all this system could be used for more natural interpretation, playback of scores. and he's implementing. I mean, he's working on that
That's
right now.
interesting.
So maybe we'll
Yeah.
we will soon have something
I
very
mean,
interesting.
two things. One is that the modern keyboards also are very sensitive and flexible to, you can with your hands. I don't remember the names, but there are keyboards that, depending on how you move your hand, they can really read.
Κλάψα.
What?
Κλάψα το λένε.
A class.
Αυτό το.
No, actually, it works
You
very,
have to
very nice
translate that.
when you, yeah. And no, because you can adjust what do you want to, what do you want to change. And for example, another something that comes to mind, that is Ableton, for example, is integrating non-Western tunings to its software. And actually, I was in communication with them. They asked me to check a bit the work they're doing, and it was very distinct contact, because a whole many issues around why are you using this, what do you want to do with this. Now, for example, they have so many different tunings, but the way they put it in the keyboard, and that's what was one of my comments, was totally unpractical. It was not designed for a musician to play them. They would create 16 tone scales or 5-tone scales, and every time you had a la, it would be repeated in different notes of the keyboard. So it doesn't really make sense, but it is also telling of the point of view and the intentions, or also the musical worldview that the programmers have, and also where do they want to drive their software to. What you were saying before about paid versions of softwares, it has to do with who you are imagining that is going to use the software, right? The program.
Yeah, and exactly, it's not practical to have a keyboard with hundreds of buttons everywhere and try to play in different.
No. Yeah. Okay. So thank you, everyone. Thank you, Natalia.
Thank you very much for the questions and for being there.
Maybe you can even, share with us the presentation, and it will be very nice. And one last thing, the Google, the first thing you talked about, the Google Open, how do you say?
MediaPi, Google MediaPi.
MediaPi. This is also open, right? It's something that
it's open.
people can enter and try. Okay.
And you can use it via browser. You don't need to use
browser.
even,
Okay, everyone, let's go there now and see our hands. Okay. Have a good night, everyone. Thank you.
Thank you.
Bye. Thank
Thank you.
you.
Take care.
Bye bye.